We need to make sure, though, that when we do our working out, we are doing it to follow the rules of bodmas. Because if we don't, we are going to make mistakes and we are not going to get the correct answer. So, I mean, my grade 8s have already written an exam, and I have written bodmas on so many exam papers because we just forget sometimes. So please make sure that we are looking at our expressions that we're needing to simplify. Oh, well, not English. Our expressions that we are needing to simplify, and we are making sure that we are doing it correctly. Okay, so first things first, guys, let's focus. I'm now on an example. First things first is we always want to know how many terms do I have in an expression. Sorry, not my laptop. If I know how many terms I have in my expression, it just helps me identify, do any of my terms need to be simplified? Now remember, if we want to work out how many terms we have in an expression, we need to look out for plus and minus signs. So how many terms are there? And when we are identifying our terms again, we are looking for plus and minus signs that separate the terms. We ignore the plus and minus signs inside brackets and inside fractions, because fractions and brackets are quite similar, but everything outside of a bracket or a fraction will separate terms. Right, I see that some people can't see my screen. I'm just going to quickly stop sharing it before we get into the example. Right, I'm going to reshare it now. Once it's reshared, you should all be able to see the screen. If you still can't, you might need to log out and log back in. So at this point, you should be able to see the screen. If not, Yolanda's also put a suggestion there of how you can hopefully try see the screen. If not, log out, log back in. But let's see if it works now. So how many terms do we have? Excellent, 3 terms. Why do I have 3 terms? Well, again, I ignore all the plus and minus signs inside a fraction or inside a bracket. So the only terms I need to consider here to separate terms are those ones that I have circled. So this whole fraction is my first term, the whole entire fraction. My second term is that positive 2xy times x times minus 2y. And my third term is this minus 5x squared y. So knowing how many terms I have is very useful, because now the next thing that I want to do here is I want to be able to go and simplify each of my terms. Can't spell simplify today. Now, guys, the reason I want to simplify each term is because I want to follow bodmas. Remember, bodmas tells me that I need to deal with brackets first, exponents first, division, multiplication, and only right at the end do we need to deal with addition and subtraction. So right now, I first need to deal with this division in the fraction, and I need to deal with this multiplication via distribution before I even start thinking about addition and subtraction. And so this is why if you've identified your terms, you can very clearly see where your multiplication or division or even exponents or brackets are taking place. Now, my advice is don't try and rush this. Don't try and do everything all in one go. Go step by step. If you need to have a little piece of paper separate for your working out, rather do that. There's no need to try and rush. So if we start with our first term, our first term is that fraction. We want to simplify that fraction. So if I just do a little block here for my first term in order to deal with that. So this is what I'm saying. If you need a working out piece of paper, by all means have one. Our first term is minus 3x squared minus 2x squared divided by minus x. Now, the very first important thing that hopefully we're seeing here is the fact that the minus 3x squared and the minus 2x squared are actually like terms. And so before I even start stressing about the division, I've got like terms that I can add or subtract here. Now, guys, remember I've said this to you quite a few times. If you struggle with adding and subtracting, really, I do encourage you to go back and rewatch the videos on integers. But what we have here is a situation where we've got negative 3x squared, and I want to take away 2 of them. So here I am at negative 3 minus 1 minus 2 takes me to a negative 5x squared. So I simplified my numerator divided by negative x. Now I can still simplify that further because remember, in front of that x, I've got that invisible 1. And we know how to divide fractions, hopefully. If we struggle, remember SNV, signs, numbers, variables. If I go to my signs first, a negative divided by a negative is a positive. So I've dealt with my signs. Then I move on to my numbers. So 5 divided by 1 is 5, dealt with my numbers. And now I go to my variables. Now again, I said this in the last lesson, but I'm going to say it again. Whenever we are multiples, whenever we are multiplying or dividing with variables, I'm going to start my sentence again because none of those words are working. Whenever we are dividing or multiplying with variables, we need to apply our exponent law. So our exponent law for division tells us to subtract the exponent. So here I've got x squared divided by x. That x technically has an exponent of 1. And so my law tells me that I need to subtract the exponents when I divide, leaving me with an x to the power 1, or you could just write x. So this simplifies to positive 5x. So this whole first term, I have gone and simplified to give me positive 5x. And I've done all of that in this orange block on the right-hand side here. So like I said, do your working out step by step. If you need to be showing this working out in your answer, that's absolutely fine, but don't try and rush it. Don't try and look at that and try and get an answer immediately. Right now I need to simplify my second term. So my second term is the distribution situation. That's a multiplication. I need to deal with that before addition and subtraction. So if I go ahead and deal with my second term now, so my purpley pink block, whatever color that is going to be me dealing or simplifying with my second term. My second term deals with distribution. So I need to deal with multiplication. I've got 2xy times positive x, and I've got 2xy times negative 2y. And I'm just going to put that in brackets to remind myself I am multiplying by a negative. Now again, grade 8, please remember that this x does have the invisible 1 in front of it. It's got a coefficient of 1. Positive times a positive is a positive. 2 times 1 is 2. Apply your exponent laws. X times x is x squared. We add the exponents. And then we've just got that little lonely y there. It's got nothing to multiply with it, so it just stays y. If I look at my second multiplication or the second distribution, positive times a negative is a negative. 2 times 2 is 4. X is all by itself. It's got no one to multiply with, so it just stays x. But the y's, we've got y times y, giving me y squared. So my second term is simplifying to positive 2x squared y minus 4xy squared. Now my third term, I can't actually do anything with that. It's not being multiplied or divided with anything. It is what it is. So it's minus 5x squared y. Right, now from this point, so I'm just going to carry on my numbering down here. Once each term is simplified, we look for like terms. Now remember guys, like terms are terms that have the same variables and the same exponents. They have to have both. So when identifying your like terms, remember that x and x squared are not like terms because one is being squared, one is just x. So once all our simplification of our terms is done, we can look for like terms. So if I grab my highlighter, I've got a 5x term. there's no other term with just an x in it. So that's it. It's got no friends. It's got no like terms with it. We leave it. My next term that I've got is a term with x squared y. I can see that I've got another term with x squared y as my third term of minus 5x squared y. They both have an x squared and then a y with the power 1. Hopefully we then see it is definitely not a like term to the minus 4xy squared, because even though both of them have got xy, we can see in this case it is the y that is being squared, not the x. And so because the exponents for your variables are different, they aren't like terms. Now, guys, remember I have said to you before, if you're more comfortable writing everything together, so grouping your like terms first, that's fine. So we've got 5x plus 2x squared y minus 5x squared y minus 4xy squared. So if you would prefer to group your like terms, that is absolutely fine. There's absolutely nothing wrong with that. So if you need to rearrange, by all means do it. If it's going to help you get to the answer, then do it. You don't have to. Personally, I don't, but that's also just my personal preference. But now you know exactly what it is you need to add and subtract. So the 5x is by itself. 2x squared y minus 5x squared y. Again, if you envision a number line for yourself, I'm currently at positive 2x squared y's. I want to take away 5 of them. So here I am at 2 minus 1, 2, 3, 4, 5 takes me to negative 3x squared y. And then that minus 4xy squared again stays by itself because it's got no like terms. Now, what's very, very important here, grade 8s, is the fact that, and hopefully you're seeing this, is the fact that when we add and subtract like terms, just going to have to give myself a bit more space here because I've been chaotic. Wait. Okay, so when we add or subtract like terms, very, very importantly, the exponents do not change. The exponents only change when we multiply or divide variables. But when we add and subtract our like terms, the exponents for the variables stay the same. Sure, okay, got that in there, stay the same. So you can see what I mean. Here, in the first term, we were dividing exponents. They changed. It went from an x squared to an x. Here we were multiplying exponents. We went from x to the power 1 times x to the power 1, then to x squared. But that was because I was dividing and multiplying. When I'm adding or subtracting, I'm not changing the exponents. And so they need to stay exactly as they were in the original term. Right, I know that was a lot of information, so I'm going to stop, take a screenshot. If anyone has any questions, now is the time to raise your hand and ask me, but just take a second, make sure, just go through everything, make sure you agree with what's happening, and if you are confused or if you have questions, please ask. And I'm obviously waiting for you guys to take screenshots. And remember, of course, grade 8s, if you do have questions and you don't want to raise your hand, you are more than welcome to post those questions on the chat, and Yolanda or I will be able to help you. All right, Senzo, do you see your hand? I've just got a question here of, can I please read what I wrote at the bottom? So at the bottom, I've said, when we add or subtract like terms, the exponents of the variables stay the same. Right, Senzo, hand?
Ma'am, may you please explain the part after the fraction after you add, then it's gonna be 2xy bracket x minus 2y. Can you please the second term, ma'am, may you please uh help
Explain
me
how I
understand how
simplified
to
it.
simplify? Yes,
Okay,
ma'am.
okay, cool. So from the second term, so let's just grab a highlighter here. So here's my second term. So people are asking me in the chat, I'm confused by the second term, so listen. Second term is positive 2xy times the bracket. So I need to distribute. That is what I have done over here in this purple block, or pinky block, I don't know what color it is. What I have done is I've taken my coefficient 2xy and I'm multiplying it to the first term in the bracket, which is x. So 2xy times 1x gives me 2x squared y. I then do the same thing for my distribution. 2xy times negative 2y now. And this is now where we need to be careful. A positive times a negative is a negative. And then we are able to find our product of negative 4xy squared. So these two terms over here that I'm underlining in purple, they have come from my second term's distribution. I am multiplying in order to get those two simplified terms. So Sensor, does that make more sense?
Yes, ma'am. Thank you.
Good. Right. Kind of multitask. Not a very good multitasker. Right. Zoom user, and please tell me what your name is so that I'm not calling you Zoom user.
Hi, ma'am.
Hi.
How are you?
I'm good. How are you?
I'm good.
What
I
is
just
your
wanted
name before you carry on so that I'm not
Oh,
calling
ma'am,
you Zoom user?
it's Yanda.
Sianda, thank you.
Ma'am, I wanted to ask because you said when you say x times x, we add the exponents, which means it's gonna be x to the power of 2. If we were to add, which is x plus x, will it be 2x or will it be x to the power of 2?
Okay, so if we're adding, it's 2x. So adding,
Okay.
we never change what's going on with the exponent. So adding is like, I've got one x, I'm putting another x there, I now have two x's. So that's why we say 2x. But multiplication is then when we deal with the exponent.
Thank you, ma'am.
Good. Camera, sorry, can you please tell me what you mean of the exponents of the variables? Okay, so what I mean by exponents of the variables, if we just go and have a look at just one of these examples, I can see that in my like terms, I had an x squared and then a y to the power 1. In my answer, that didn't change. I've got an x squared and a y to the power 1. So those exponents of the variables in my like terms haven't changed at all. Okay, so that's what I mean. Alrighty, guys, I'm hoping we've all got that. Just quickly down here, I've just typed out what I've just typed out what I wrote in green because I recognize that my handwriting went a bit weird there. So hopefully you've got that now as well. But let us have a look at a second example. So last 3 seconds to take screenshots. When I put up this example, my first question, and I want to see your answers in the chat, is I want you to tell me how many terms are there in this expression. Okay, so gosh, again, I need some more space for myself. So here's your expression. My first question, how many terms do I have? I'm going to wait for some answers there on the chat. Because remember, like I say, one of the most important things is to know how many terms you are working with before you start simplifying. Chaos on my side. Sorry, guys. Good, grade 8. Well done. We're getting the hang of terms. Alrighty, please remember, let's not spam the chat. So we have indeed got 3 terms here. Remember, I ignore all the signs that are in the fraction or in the bracket. So the only signs I care about are these two that I'm circling, which means that they are separating terms. So here's my first term. Second term is the distribution. Third term is just that little 3x all by itself. So we're going to do exactly the same thing. We've identified our terms. Now we want to simplify each of our terms. So if we start with our very first term, which is the fraction, we need to have a look and see what's going on here. Now, guys, the very first thing that I'm hoping you notice is that minus 4x and minus 2x, they are like terms. And because they are like terms, it means that I can add them together before I start doing anything else. So because they are like terms, I can immediately say, okay, well, this actually simplifies to 3xy times minus 6x. Minus 4x minus another 2x is minus 6x. That is then being divided by the negative 6. Automatically, that is a bit simpler than what I started with. Right, we'll simplify as we go along. But so far, I've done a little bit to my first term. I'm starting to simplify it. So what I'm doing here, guys, is your English. Okay, I'm just going to leave my words for a second. If we look at term 2, remember I said this is now distribution. We're taking this negative 4x and we're multiplying it to the 2x squared and to the 3xy. So if we do our little multiplication block for ourselves, we have got negative 4x. I'm just putting it in a bracket to remind myself that it's negative, times positive 2x squared, and then negative 4x times negative 3xy. Okay, so I have got my little multiplication block. I need to do this distribution. Just want to make it a bit bigger. So for the first one, a negative times a positive is a negative. 4 times 2 is 8. Now remember your exponent rules. X times x squared. That x has an exponent of 1, so we would add them, giving us x cubed. For my second product, negative times a negative is now a positive. 4 times 3 is 12. X times x is x squared. And then shame, I've got this little y all by itself, so it just stays like that. So this second term is simplifying to, oopsie daisies, minus 8x cubed plus 12x squared y. My third term, it's got nothing really going on there, so this is just plus 3x. It's not being divided or multiplied, exponent, nothing like that, so just leave it. I'll deal with it in a second. If I now go back to my first term, I've still got some simplification that I need to do there because I've still got the multiplication and I've still got the division to deal with. So let's deal with that multiplication. I need to say 3xy times negative 6x. Okay, so sorry. So a positive times a negative gives us a negative. 3 times 6 is 18. X times x, x squared, and then we've just got that y in the numerator, so minus 18x squared y. That is still being divided by the negative 6. So I'm slowly but surely simplifying as I go along. It's taking me a bit of time, but that is also absolutely fine. Remember, like I said right at the start of the lesson, rather take your time and get it right than rush and make silly mistakes. So back to our first term, all the other terms stayed the same. They're simplified. I'm not doing anything more. I now need to deal with this division. A negative divided by a negative is a positive. 18 divided by 6 is 3. So I've got positive 3. There's no variables in the denominator. So this is just 3x squared y. Those variables can't be cancelled or divided. There's nothing in the denominator to cancel with them. So they stay as they are. And then we've got our other terms, the minus 8x cubed, hello, plus 12x squared y. Weird looking cube. Let's try that again. And then our plus 3x. Now remember, once all of your terms are simplified, this is now where we go and look for like terms. Same variables, same exponent. So if I look at my very first term, this is one that has an x squared and a y. So I go to my terms and I see, do any others have both an x squared and a y? Yes, 12x squared y. So those two are like terms to each other. Unfortunately, I see that I've then got an x cubed, and that doesn't have a like term. It's x cubed. There are no other terms with x cubed, so that's by itself. And then I see that this 3x is also a group by itself because its variable is x and its exponent 1. Sorry, on the chat, Mikle, is it a 12 or a 6? I'm assuming you mean this over here. That is a 12x squared y, but if that's not what you mean, please let me know. Did go a bit weird, but it is a 12. Now we can add and subtract our like terms. Remember, if you need to write your like terms together, that's fine. So 3x squared y plus 12x squared y minus 8x cubed plus 3x. So I've just grouped my like terms. You can if you want to, you don't have to. It is entirely up to you. It really makes no difference, whatever you're more comfortable with. And now we add and subtract our like terms. So I've got 3x squared y plus 12x squared y, which gives me 15x squared y. And then the rest of my terms have no like terms, so they just stay exactly as they are. So this is my final simplified answer. I have no more like terms, can't do anything with that, stays as it is. So again, take your screenshots. If you have questions, please ask. In grade 8, whilst these are, I don't want to say these are super, super hard questions. We could be really mean if we wanted to, but these are definitely the types of questions you will be asked. So you need to be comfortable being able to do what we are doing here in an assessment. And so if you can follow those 3 steps that we outlined here in the first question, you should hopefully be okay to simplify any expression that we give you. Right, so again, questions, you can raise your hand or remember the chat's there. Otherwise, you're taking screenshots. Good, grade 8. Right, so I think you're deserving of a brain break. I am also just going to put the Maths 24 values here again, in case you want to try it. Because I'll be interested to see if anyone comes up with another method. So the 4 numbers that you have to use were 5, 5, 7, and 4. So if you can come up with a way to get 24 using those 4 numbers. Otherwise, here's your brain break. I'm going to make it a bit bigger. Remember, look out for the doubles. So look out for 2 ducks, 2 otters, and 2 cows. And I want the final value. So when I say final value, I mean I would like the value of this equation down at the bottom here. I need to get my answers as well. Remember, put it in on the chat. We will keep an eye out. I'm hoping that I'm going to be faster than you. right, if you are going to put answers for the Maths 24, actually, no, it's pretty clear what's happening here. Okay. Right, let's see what's going on here. Okay, so we've got one method for the Maths 24. Well done, Boitu isn't there. Monomoke, you're on the right track. Just where did the 74 come from? Unless I'm losing my mind. And just be careful, 14 minus 74 isn't 24, it would be negative 60. So unless we've just made a mix up with our numbers there, just be careful. Renilway, well done. I'm hoping this is, well, it has to be for the brain break. Renilway, if you want to raise your hand and let us know how you got that answer. Amazing, cool, tell us.
Hi, ma'am.
Hi.
So, ma'am, the tax are 8. And
Good.
because it's 2, it is 4 plus 4. So it comes to 8. And then 8 plus 8 plus 8 equals to 24.
Good, excellent.
And then the next one, it is 8 multiplied by 18 plus 8.
Good.
And then the next one, it is 18 multiplied by 12 plus 18.
Yeah, sorry. Yeah, good.
And then, ma'am, the next one, it is 6 times 4 equals to 24 plus 18 equals to 42.
Excellent. And guys, what was really, really nice there that Renilwe did was starting with the multiplication. We have just done an entire half an hour on how important order of work is. And so Renilwe identified the fact that we have to do the multiplication first. Renilwe, can you just tell us why that 1 cow is 6 and why 1 duck is 4? Just so that everyone is clear.
Can you please repeat the question, ma'am?
So we worked out here that 2 cows was 12 and 2 ducks was 8. So how did we get that 1 cow was 6 and 1 duck was 4?
So, ma'am, for the ducks, we divided 8 by 2 because the ducks are 2. And then for the cows, we divided it by 2 because the cows are 2.
Excellent. So guys, remember when you've got 2 of the image, whatever it is, if you then only have 1 in the next step, you need to divide it by 2. Excellent, Renilwe, well done.
Thank you, ma'am.
Okay, amazing, guys. So hopefully that went well for most of us. Just quickly, the Maths 24, some of you came up with a way that I didn't even think of, and it's so much easier than the nonsense I was trying to do. So 5 divided by 5 gives us 1. 7 minus 1 is 6. 6 times 4 equals 24. So excellent. I made some weird choices in life, and so what I did was I said 7 minus 5 gives me 2. 2 squared gives me 4. So I've used the 7 and the 5. Then I said that 4 times my second 5, which is 20. And then I added the last 4 to give me 24. So I made some weird choices in life, but we all ended up getting to 24. So pat on the back for all of us. Well done, us. Well done for getting that Maths 24, guys. I'll be honest, I sat and struggled for a while. So well done, you. Alrighty, let us go back to some algebra because we all love algebra. Oh, my nose. Righto, so let us have a look at our third question over here. I've definitely not left myself enough space, so give me 2 seconds. Okay, so third question, I want you to try this by yourselves. So identify how many terms you have, simplify each of your terms, and then double check for like terms. So please give this one a try by yourselves. It is going to take a little while, so there might be just some patches of silence, which is absolutely fine, but I want you to try it. Okay. Just quickly, if you are trying to put in the chat an exponent, to do that, so if you, for example, on the chat want to type x squared, what you want to do is you want to type the x. You then want to hold shift 6 to give you like a little hat looking thing. And then you would type 2. That is telling you x squared. The hat thing is pointing up to where the exponent would be. And so it's telling us we have an exponent of 2. So give it a try. I just need to run and get a tissue. My nose has decided not to function. But I will be back in 2 seconds.
Let's go, my people. Let's go, guys. We can do this. Are you guys gonna try it? Are you trying it on your books? So make sure that you try it, right? Make sure that you take the first term, you simplify it nicely. And then the second term, you need to do FOIL. And then after that, we can simplify. But you need to make sure that you start with the first term to try and figure it out what to get. But basically, it's just take the first term, put it aside, simplify it, see what you get. Come to the second term, do your FOIL, simplify, see what you get, and then you add your third term, and then you can check like terms and sort it out in that order. Okay, it's doable, guys. I believe in you guys. Y'all can do it. Let's go.
Good time, guys. Well done. Oh. Okay, so exactly like Yolanda said, identify your terms and then go term by term. Don't rush it. Hopefully you've also been taking screenshots as we've gone along. So you've got your screenshots to refer back to if you need to double check how we did the previous 2 examples. Oh, golly, Miss Molly. It's just like one nostril that's decided that it doesn't want to breathe anymore. Maths is going to get harder and harder, but this is why it's also so important that you come to our Watobe lessons, because we make sure that we've got the foundation solid. And so if your like your teachers tell you this all the time, if your foundations are good and you know the basics of maths, then it's getting harder shouldn't scare us. All right, guys, I'm going to give you another few minutes. Like I said, I know it's going to take some time, so even if we start going through the answers before you're done, that's cool. Correct it as you go along up until the point, and then you can get the answer. But I'm going to give you, let's say, another 3 minutes. Falling apart. I got the cutest stickers. And this might only be something that some of you appreciate when you're older. If you're feeling stuck, guys, that's absolutely fine. You can ask your questions in the chat, but you can also just be stuck. That's also okay. Yolanda, you might appreciate these a little bit more than everyone else. So there's one with, you make it look as easy as pie.
Oh, wow. Yeah.
Awesome work. What was this
Oh,
one?
my word.
You're right with a right angle. And this
Oh, my
one was
God.
work is on point.
Wow, that's amazing. Where did you get that?
Teachers Trove. It's like an online teachers accessory thing. I love stickers. Love putting stickers on work. I know I teach high school.
Amazing, though.
So like 18-year-olds get stickers.
Exactly. It's a good thing for them. It's a reminder. I love it. Even at my old age, I would appreciate to have.
Oh no, I love my stickers. I actually have so many. It's actually ridiculous. I need to just stop.
Nice. I see all of you guys are trying. That's amazing. Nice, my
Give me one more minute. Oh. So guys, remember, like I said, if you're struggling, that's fine. Sometimes it's actually good to struggle because it means that you can double check your working. It means that you can double check where you've maybe misunderstood something or where you have understood something and then have just not been 100% sure of what your next step is. So it's fine to struggle. Like we struggle now in our lessons so that hopefully when it comes to quizzes and tests at school and all the rest of it, we feel more confident. Okay, I still struggle with things sometimes. Sometimes even the most basic of things, my brain has a brain fart. And that's okay. Struggle is good. As long as you then learn from the struggle and you can do it better next time, struggling is good. Right, I'm going to blow my nose and then we're going to have a look. Alrighty, so let us see. First things first, we want to know how many terms that we have in our lovely expression over here. Hopefully we all saw that we have got 3 terms. We've got our fraction, distribution, and then the lonely little term at the end there where we've got nothing going on. So now we want to simplify each of these terms. Okay, so if we look at the very first term, we have got a fraction that we need to simplify. So again, if we just do our little working out block for our first term, let's see what we have going on here. So this is minus 12x cubed y to the power 4 divided by minus 3xy squared. Okay, now guys, remember, whenever you are multiplying or dividing, SNV is very useful to us. SNV is signs, numbers, variables. If you can do it in that order, just break it down for yourself, life becomes easier. So if we start with the signs, a negative divided by a negative is a positive. So signs are dealt with. Now I'll move on to my numbers. 12 divided by 3 is 4. Numbers dealt with. And then I'll go on to the variables. Now remember, anytime you're dealing with variables, you need to apply your exponent law. So for example, here we have got x cubed divided by x. We can only work with the same variables. Now our exponent law tells us that in order to simplify or in order to divide, we have to subtract the exponent. So this would be 3 minus 1 because that x has an exponent of 1. And so that simplifies to x squared. Personally, I just cross cancel. So I see I've got 3 x's in the numerator, 1 in the denominator. 1 can cancel with 1 at the top, leaving me with 2. Gets you exactly the same place. And so whatever you would prefer is completely up to you. but we simplify to x squared. We're going to do a very similar thing with the y's. If you choose to subtract the exponents, 4 minus 2 is 2. If you choose to cancel, you're going to cancel 2 at the bottom with 2 at the top, leaving you with y squared. So this first term simplifies to 4x squared y squared. Because it's the first term, I don't have to put the plus there. You can if you want to, but because it's a very first term, we don't have to put the sign there. Right, now I need to deal with my second term. My second term is distribution. I am taking, my body is just gone tonight. I'm taking the xy squared and I'm multiplying it into my bracket. Now, before I do that, hopefully what we see is that these two terms are actually like terms. So before I distribute, I can simplify this to get to get xy squared times, and minus 4x minus 2x is minus 6x. So I'm simplifying my bracket before I distribute. However, grade 8, if you didn't see that they were like terms and you distributed, it is fine. The like terms will still be there just with the distribution, and so you'll simplify it correctly. So if you didn't see the like terms, as long as you've distributed correctly, you will still get the same answer. Right, so we'll come back to that. The third term, shame, it doesn't really do much. It's just minus xy because I can't simplify it any further. But the second term, I can definitely simplify more. So my first term stays as it is. It's simplified. I've dealt with it, no issues. But now the second term, I want to multiply. So I have got positive xy squared times negative 6x. A positive times a negative is a negative. Remember, in front of this xy squared, there is a 1. So 6 times 1 is 6. X times x is x squared. And then I've got the y squared there. It's not being multiplied by anything. It just is. So minus 6x squared, y squared. Remember, guys, over here, I'm also using SNV again. So I'm not just making up these steps. I used SNV. Signs, negative times a positive. Numbers, 1 times 6. Variables to get my x squared, y squared. Now that I've done that, I can check for like terms. So looking at what I have a term with x squared, y squared. I see that I've got a second term with exactly the same exponents and variables, x squared, y squared. Unfortunately, my little minus xy is all by himself, doesn't have any like terms, but that's okay. We'll still include him at the end. So to simplify my like terms, again, if we need a number line to do this, we have got positive 4x squared, y squared. We want to subtract 6. So there I am at positive 4x squared, y squared, minus 6, 1, 2, 3, 4, 5, 6. Takes me to negative 2x squared, y squared. And then I still include my minus xy because it's still part of my expression. It just doesn't change because there were no like terms. Okay, so very, very nicely done if you got that. If you didn't, please make sure you have checked to see where you made a mistake, where maybe you didn't understand something, so that you can make your corrections.